Okay, here we want to use the washer method to find the volume of a solid of revolution formed by revolving y is equal to x squared and y is equal to x about the x-axis. Now, as we've already talked about, the washer method is an extension of the disk method. The difference when we use the disk method, we have one function, but when we use the washer method, we usually have multiple functions where we have to carve out an outer radius minus an inner radius. So the first thing we want to do, just to get a somewhat visual representation of it, let's try to draw our graph. So first we want to draw y is equal to x squared. So we know that y is equal to x squared is the graph of just a base parabola. Okay. And now let's look at y is equal to x. As we know, y is equal to x is a straight line, a diagonal line going directly through the origin. Okay, so what we're trying to do is find this little green area, find the volume of this green area that's encompassed by the line and the parabola. We can see that it goes from 0 to 1, but as we said when we were doing the area, when we don't know or we're unsure about the boundaries, or they're not explicitly provided to us, what we do is set the functions equal to each other, and find our boundaries. So we have x squared is equal to x, and we solve for x. So of course, x is equal to 0 and x is equal to 1, which is precisely what we thought. I'm just going to draw these little lines. That would be x is equal to 0, and this will be x is equal to 1. Okay. So now what we want to do is set up our problem with the formula. So as we know, it's the outer radius squared minus the inner radius squared. So in our case, the line is the outer radius. It's on the outside of the x-axis. So we would set this up in the following. B is equal to pi. Remember, we found our upper and lower bounds, which are 0 to 1. And that would give us x squared minus x squared squared. Okay, we go to our next step. Just want to simplify more here. That will give us x squared minus x to the fourth. Now for our step of calculus, the antiderivative of x squared gives us x cubed over 3 minus x to the fifth power over 5. Now here we have to evaluate this from 1 to 0. So we simply say 1 cubed over 3 minus 1 to the fifth over 5. And all of that is minus 0. This is 1/3 minus 1/5. Once we get our common denominator, which is 15, that's going to be 5/15 minus 3/15, which gives us 2 pi over 15. So this is just a quick example of how we would use the washer method.